Dear learners, in this session we will discuss with such a kind of state of matter which is the blend of solid and liquid, and this kind of state of matter is known as liquid crystals. We have seen that to convert solid into liquid or to convert liquid into solid we need to vary temperature. With the application of temperature, by the means of process of melting, you can convert solid into liquid. And in the same way, by means of freezing, you can have solid from the liquid. So, the intermediate between these two, from the conversion of solid to liquid or from liquid to solid, there is existing one intermediate phase that is known as liquid crystal. So it is the state of matter that is the blend of the structure and properties of the liquid and crystalline solid states. When you are observing the liquid crystal, you will observe that the state is separated into parallel layers, and these layers are in crystalline order. So you can say that this kind of state of matter is called as mesomorphic phases. So you can convert or you can say liquid crystals as a mesophase. So the appearance of this liquid crystal is a turbid in nature. That's why it has a near to semi-solid appearance. So the based on this one, as we have seen that they are having structure and blend of structure and property of your solid and liquid, then obviously the properties are the blend of your solid and liquids. The properties of liquid crystals are orderly arrangement, they are having optical activity like your solids, and some of the properties of liquids like your fluidity, viscosity and surface tension. So you can say that the properties of these liquid crystals are nothing but some of the properties of solids and some of the properties of liquids. In order to deal with each property, let's first of all focus on the orderly arrangement. In the liquid crystal state, the increased molecular motion overcomes the weaker forces. But though the molecular motions are overcome by weaker forces, the molecules remain bound by the stronger forces. This bounding by the means of stronger force produces a molecular arrangement where the molecule is layered, but within each layer you will have their random position. In the same way, when it comes about the optical activity, we are quite aware that your liquids are isotropic, means they are having all the properties uniform in all directions, whereas your crystalline solids are anisotropics, that is their properties are varying with direction. But in the case of liquid crystal phase, many of the physical attributes of the liquid and some of its molecular units are sufficiently ordered to give rise to some anisotropy. The anisotropy of liquid crystal causes them to exhibit birefringence. You know what is meant by birefringence? Birefringence stands for when you are having the light ray that enters the crystal, that light ray is broken up into two oppositely polarized rays, and these two oppositely polarized rays travels at different velocity, and you are saying this as a birefringence. So observation of birefringent material between crossed polarizing filters reveals the striking pattern and color effects. The molecule can slide one around the other, so they will have fluidity. So as these molecules ordered in a crystalline or liquid structure, they can slide over one another and they can slide in layer form only. But this molecular mobility generates fluidity in liquid crystal states. So the mobility or the fluidity is in the form of layers. It's not about individual molecule. It's about the fluidity of complete layer. When we are observing the semi-solid appearance of your liquid crystal, then it will have cloudy appearance, and which means that they can scatter light in much way as like your colloid, that is your milk. And this light scattering is a consequence of fluctuating regions of non-uniformity as small groups of molecules form and disperse. Means they can form a small groups or they can disperse into the surrounding. So when it comes about this dispersion, there is thermal expansion. Thermal expansion is responsible for this dispersion. As you are increasing the temperature, the average space between this aligned molecule will increase and they will disperse, and it will result into loss of turbidity as well. As like other liquids, it do possess surface tension, and surface properties of molecular model of a liquid crystal can be studied using density functional theory. The intermolecular interaction includes all the terms which are responsible to break the orientational symmetry at the interface. So, the properties of solids like your order of arrangement and optical activity, and the properties of liquids like your fluidity, viscosity and surface tension converts a blend of properties which are nothing but the properties of liquid crystals. There are three basic types of these liquid crystals, or there are four basic types of liquid crystals, and these types are based on the arrangement of molecules or its symmetry. And based on this, these liquid crystals are subdivided into four main types, or what is scientifically known as mesophases. And the four types are pneumatics, cholesterics, smectics and columnar. Let's see one by one. Moving toward pneumatics, the pneumatic phase is the simplest form of liquid crystal and is the phase in which the crystal molecules have no orderly position and they are free to move in any way as they want. However, while they have no specific order, during this phase the molecules do tend to point in the same directions. So as you can observe on your display, the pneumatics are the simplest form of liquid crystals, but all these forms are arranged in no order position. There is no alignment, there is no structured arrangement within your pneumatics. The next type of liquid crystal is cholesterics. The cholesteric phase is also known as chiral pneumatic phase, and this is because the molecules are characterized by being aligned. The molecules are aligned in a proper position. Comparative to pneumatics, in cholesterics you will observe that all the molecules of your cholesteric liquid crystals are in aligned position and they are stacked within very thin layers. So if you are observing the difference between the arrangement of your pneumatics and cholesterics, then pneumatics are unorganized whereas your cholesterics are organized one. The third class is your smectics. The smectic phase of liquid crystal is characterized by a slight degree of translational order in their crystal molecules. They are having orientation with orderly position. The slight degree of translational order in this phase, because of this, the molecules tend to line themselves up into the layers, while these layers as a whole move freely. Means they can, when it deals with the layer individually, as on your display, you are observing dotted lines between the two molecules which are aligned or arranged in a ordered position. Then this dotted line says that the molecules can move in a form of layer. Say as a whole they can move freely, but the movement is restricted within the layer. Means if you are dealing with the upper layer, that can move. If you are dealing with the second layer, that can move, but they can't move from one layer to another layer in a structured arrangement. The next type of your liquid crystal is your columnar liquid crystal. They are formed by disc shaped molecules. They are hexagonal, rectangular or herringbone structure. Their dimension is two-dimensional lattice and they can occur in a columnar arrangement. In the herringbone, mesophase molecules are tilted with respect to the columnar axis. Means the axis that separates them are responsible to undergo tilting. So the rotation is around this axis. The various uses of liquid crystals, as you are dealing with cholesterics, they give you colored appearance. So based on this, they are used in a temperature sensor in a thermometer. They can sense the temperature and have change in color. So that will be the key point to determine the temperature sense in your thermometer. The next use of your liquid crystal is to find the point of potential failure in electrical circuits. If your electrical circuit won't work, then what kind of reason or where the actual potential failure lies, you can determine by means of liquid crystal. In the same way, if you are having some kind of blockages in your vein and arteries, if you are having infection or tumors in your skin, then you can easily locate these blockages or you can easily plot a skin thermograph by using these liquid crystals. You can use liquid crystal as a display in your electric devices like your digital watches, calculators and computers. And you can use liquid crystal as a solvent in chromatography. So you can observe that they are having wide variety of applications in your diagnosis. They are having wide variety of applications in your chromatographic studies, and you can do use your liquid crystals as the displays in electronic devices. So this was about liquid crystals. Thank you.